Okay. Thank you everyone for joining me today. Again, my name is Mara and I'm an honors student and I'm usually located in Townsville, but I'm connecting to you all the way from Germany today. So welcome. Today I want to give you some insights into my research about the economic evaluation of the effectiveness of the Reef Trust Tenders. The tenders are a program designed to reduce nitrogen runoff entering the Great Barrier Reef. Before I delve into details, I want to quickly acknowledge my two amazing supervisors, Dr. Diane Jarvis from JCU and also Dr. Stuart Whitten from CSIRO. And I also want to acknowledge and thank the two for providing me the essential data for my research. So throughout my presentation, I really wanted to answer three fundamental questions. The why. Why are we doing our research? Why is it important? The what did we do exactly and what have we found? And also the so what. So what does it all mean and what kind of conclusions can we draw from our research? So let's start with the why. Why is our research important and why are we doing it? We are all aware that the health and the resilience of the GBR has significantly declined, and it faces several threats, and including climate change, of course, but also through agricultural pollution. And specifically, if we focus on nutrient pollution, it is estimated that around 10,500 tons of dissolved inorganic nitrogen are exported from the GBR regions each year with severe consequences to the reef. And despite an over $4.4 billion investment from the Australian Queensland government through various policies and programs to support the Reef 2050 long-term sustainability plan, progress towards reef targets, which also includes improving water quality through reducing overall pollution entering the GBR, remains rather slow and insufficient. And the existing literature suggests that part of this slow progress can be attributed to ineffective policy design, along with a lack of critical evaluation. And our study really aims to bridge this gap by evaluating an initiative aimed at reducing agricultural pollution. And we do, of course, acknowledge that there have been evaluation studies related to reef programs prior, but they often rely on contracted information, resulting in estimations rather than definite insights. And our study draws on contracted information, but also on verified on-ground data. And through our findings, we really aim to provide insights into effective policy design that will contribute to the 2050 reef targets and in turn enhance the resilience of the Great Barrier Reef. Now, before I continue with the what, I do want to give you a quick little background of the reef tenders. So the tenders have been designed to address nitrogen losses and specifically dissolved inorganic nitrogen, or short DIN from now on, coming from sugarcane farms from the Burdekin and Wet Tropics regions. And DIN losses in both of those regions have been recognized as one of the highest risk land uses affecting the health of the GBR. Now, here's how the tenders work. They are a reverse auction program where farmers submit a proposal or a payment required to implement some practice change that reduces DIN runoff from their properties by an amount the farmers also specified. And these proposals are then evaluated based on their cost effectiveness. So cheaper proposals that are those that can reduce nitrogen at a lower cost per unit are preferred and recommended over the more expensive ones. In essence, this is a competitive process that ensures that the most cost-effective projects are chosen. And the main objectives of the tenders were to reduce DIN discharge long-term, increase engagement, participation, and uptake of improved nitrogen management practices, as well as create a cost-effective investment that improves reef water quality. Now that we have a bit of background, let's continue with the what. What did we do and what have we found? Our study uses farm-level panel data from 34 sugarcane farms in the Burdekin region and specifically covering tender rounds 1 to 3. I do want to note that there have been pilot studies prior and also tender rounds in the Wet Tropics, But for this analysis, it is based solely on the data from the Burdekin tender rounds 1 to 3, as access to data for those rounds was provided by DITU. And for my presentation, I really wanted to pull out some of the key questions that guided our research. Firstly, and most importantly, did farmers reduce their nitrogen application? Were there any instances of overabatement? That is, did farmers achieve any additional reductions beyond the requirements of their contracts? Were those changes statistically significant? Were the tenders cost effective? And also, to what extent and by how much did they actually contribute to the 2050 reef targets? Now, moving on to what we have found. Our data shows that around 10% of total sugarcane area in the Burdekin was contracted over the tenders. There was an over 966 ton reduction in nitrogen applied, and that includes a 300 ton overabatement. The tenders achieved a 20% reduction application rate, and the t-test confirmed the significance of those results. If we look towards cost effectiveness, the average cost was $6.20 per kilogram of nitrogen reduced at the paddock scale. If we then translate this to the end of catchment DIN cost, it equates to around $63 per kilogram of DIN reduced. Regarding the reef targets, our analysis shows a considerable contribution, over 20% towards the Burdekin reduction target and a 3% towards the whole of catchment reduction target. Interestingly, what we have also found is that farm size mattered, with larger farms playing a substantial role, contributing to around 71% of the overall nitrogen reduction. Now that we have some of those results, what does it mean? So firstly, what we can say is that the Reef Trust Tenders were a success. They met their primary objective by reducing nitrogen application and exceeding it with an additional 310 tons. And the cost effectiveness stands out also. The average contracted cost of nitrogen reduction was initially $9.13, but our data shows that they actually achieved a significantly lower average price of $6.20 per kilogram of nitrogen reduced. Again, when we translate this to the end of catchment DIN reduction cost, the tenders achieved their goal for much less than other programs in this space. And to put this into perspective, the recommended maximum benchmark price for DIN reduction is at $150. However, the tenders achieved a reduction for less than half, for just an average of 63. Now, what kind of conclusions can we draw from these findings, and what can it mean for future policy program design? What the data tells us is that we could do more of it. The data underscores the success of the Reef Trust Tenders in reducing nitrogen application, therefore DIN discharge into the GBR, not only delivering the contracted reduction, but actually overachieving by a large margin. The cost effectiveness of the tenders is a key finding as well. It not only underscores again their effectiveness, but also suggests that well-designed programs like the tenders should serve as the gold standard for future environmental initiatives. And policymakers and stakeholders can look to replicate this model to achieve similar positive outcomes across catchment and even across pollutant types. Encouraging larger farm participation should also be a key consideration in future policy design. To sum up this presentation, the Reef Trust Tenders result really highlight the effectiveness of reverse auction environmental programs and offers valuable lessons for achieving environmental goals and safeguarding ecosystems like the GBR. As we move forward, what's important is that programs are carefully designed and robustly evaluated to learn any key lessons. And this will be key to ensuring the continued success of initiatives aimed at protecting our precious natural resources. That brings me to an end. Thank you so much for listening. I'd love to hear from you if any questions or feedback. Thank you.